Hi! So this is our lab number 2 where we had to create a working submarine.
So in the first part of the video, you will see us talking about the theory behind our submarine, why it works, and the mathematical reasons why it works. And in the second part, you're going to see us making and proving that our submarine works. Okay, so in this part of the lab, we're going to explain to you the mathematical reasons and theoretical reasons why our submarine works.
We first started by finding the density of the saline solution we put it under. And so we found on the internet that the formula was density equals the total mass on the total volume.
Okay, so basically for the first step, what we did was find the total mass. To find the total mass, we had to find the mass of the water, and we know that its volumetric mass is 1 gram on 1 milliliter. So because we use 150 milliliters, we can conclude that we used 150 grams. And the mass of the NaCl was 30 grams because that's what we used in the lab. We add those two together and we obtain 180 grams.
Then we found the total volume of our solution by adding the volume of our water to the volume of our NaCl. So we knew that the volume of the water that we used was 150 milliliters. But to find the volume of our NaCl, we used again the volumetric mass of NaCl, and so we knew that by using 30 grams of NaCl, we used 26.1 milliliters because the volumetric mass is 1 milliliter of NaCl on 1.15 gram of NaCl. To find the total volume, we added 150 milliliters and 26.1 milliliters together, and we obtained 176.1 milliliters for total volume.
Finally, we found the density of the saline solution with our formula, that was the mass on the volume. And because we found the first step that we had 180 grams total and 176.1 milliliters in total, we can divide those together and find that the density of the saline solution is 1.0221 grams per milliliter.
And so we knew that the density of the saline solution that we recreated in a laboratory is approximately the same as the density of seawater, because the density of seawater ranges about 1.02 grams per milliliter to 1.03 grams per milliliter. So now the second step was to find the density of the distilled water, and we found that the density at standard temperature was of 1 gram per milliliters, and this we found it on the internet.
We then compared the two densities. So we know that the density of the saline solution, that is 1.0221 grams per milliliter, is higher than the density of the distillated water that we found is 1 gram per milliliter.
And so here we did a representation of our lab. So we can see that the saline solution is underneath the distilled water because of their different densities. So because the density of the distilled water is lower than the density of saline solution, it floats on top. And so then we represented here our piece of cardboard, and because it was floating in between those two waters, we determined that its density was between those two, so meaning that it had to be bigger than the density of distilled water, so it could sink through the water, but it had to be lower than the density of the saline solution because it was floating on top of it, so that's why it was between the two waters. Thank you.
There's like two faces of this water. You see that this is the sodium chloride and this is the distillated water.